So I want to talk briefly about determining percent composition. So really, if you look at this section, this is chapter 3.4, I believe, in Zumdahl. It's mainly examples. You learn how to do percent composition by doing percent composition. So I'm going to just go over an example with you, and I think that'll bring out some of the things that you need to worry about when you do this. So my example says that penicillin was discovered by Alexander Fleming in 1928. Penicillin F has the formula C14H20N2SO4. Kind of an interesting story with Fleming. He was a bacteriologist, and of course he would develop cultures inside of petri dishes. So he had some petri dishes, and he didn't actually inoculate the petri dish, the agar that's in there, like he normally would. The story goes that he actually had a cold at the time and he sneezed on it. So he sneezed on this petri dish, but he was supposed to be going to a conference or something of the sort, and he didn't have time to clean up the dish. And so he set the dish aside thinking, I'll clean it up when I come back. Well, when he came back from the conference that he was at, he looked at it, and like the rest of his experiments, there was bacteria growing in the petri dish. But everywhere where he had sneezed and mold had started to form on the sneeze, he found that there was a halo around that spot where no bacteria was growing. So he actually discovered penicillin completely by accident. It was mold that was growing on his own snot, essentially, that actually produced penicillin. And that went on, that penicillin went on to save thousands and thousands and thousands of lives during World War II, in particular because before that, people that got injured, especially during World War I, they got injured, they would develop a bad infection and it would kill them. So having penicillin, he found out that, hey, you know what? That bacteria that caused the infection, penicillin kills it. So sometimes things just happen totally by accident. Anyways, back to this. So I've got this formula, and I want to compute mass percentages of all the elements that are in it. The way you do this is very similar to the way that you would determine your own grade in a class. I'm going to take the number of points that I earn, and I'm going to divide it by the number of points that are possible, and that's going to give me a decimal value. It's going to be some fraction of what was possible. And then I multiply by 100%. That's going to give me my percentage in any class that I'm in. So what we have to do, kind of using that train of thought, here's the entire compound. I need to figure out, well, what's the mass of the whole thing? And then what's the individual mass of each part? If I divide the amount of mass that each element gives me by the total, I'm going to get a percentage just like your grade. That's how this works. So if I go through and I do this, I have 14 carbons. And I know that carbon has a mass of 12. That would be 140 plus 28 should be 168. All right. Hydrogen's easy. There's 20 of them. We know it has a mass of 1 on the periodic table, so this would total 20. Nitrogen's 14, and there's 2 of them. That's 28. Sulfur, there's only 1 of them, and it has a mass of 32. And then oxygen, we know, has a mass of 16, and there's 4 of them. 4 times 16 should be 64. All right. So if I just add all of these numbers together, 168, 188, 208, 216, 246, 248, 308, 312, I believe, is the number that I get. So it should total 312 is my total mass. And I just realized I screwed up because I have no microphone. Oh, yeah, I do. Microphone's working? Awesome. So we'll get rid of that. All right, so our total mass is 312, and we also have each one of the individual masses. So this becomes pretty simple now. All I have to do is I'm going to take them one at a time. My percent carbon is going to equal the mass of carbon divided by the total mass. Then, of course, I'm going to multiply by 100% to convert it into a percentage. So, mass of carbon is 168. I'm going to divide that by the total mass, which was 312, times 100%. And I'm not that good. I'm going to have to do this with a calculator. Okay, so I have 168 divided by 312. I get 53.84. I'm just going to call that 53.8% carbon. Okay? On to the hydrogen. Again, I'm going to do it the same way, except I'm going to use the mass of hydrogen instead of the mass of carbon. So I'm going to kind of go straight to here. So I know that the total mass of hydrogen is 20 grams for every 312 grams total, times 100%. $20 divided by 312. Let me double check that. I get 0.0641. So this is going to be, if I multiply that by 100%, that's going to be 6.41. I'm going to stick with 3 sig figs on all of this. So I may have an extra decimal here, but that's okay. And this is going to be hydrogen. All right, so by mass, 6.41% of this compound is made up of hydrogen. Nitrogen, taking its mass, which is 28, for every 312 grams total, times 100%. $28 divided by 312. So that's going to give me 13.1%. So 13.1% of penicillin is made up of nitrogen, sulfur. Sulfur had a total mass of 32. I'm going to divide that by 312. Times 100%. $32 divided by 312. I get 10.256, so we'll call this 10.3% sulfur. And lastly, percent oxygen. Our mass of oxygen total was 64 grams of oxygen. The total mass is 312 grams total times 100%. $64 divided by 312. I get 20.5. Okay, now, at this point, I pretty much have my percent composition. The answer would essentially be all of these numbers. Now, you might have been sitting there and saying, well, these have to add up to 100. You'd be right. They should add up to 100. Kind of move over to the side over here. They should add up to 100, but what I don't want you to do is get down to this last one and just say, all right, well, I'm going to add those together and then just subtract from 100 to get this percentage. Why do I want you not to do that? Well, if I messed up one of these numbers up here, that means this number would also be wrong if that's the way I did it. So I would much rather have you use that 100% total as a check on your work. It's easy to miscalculate something and not come out correctly. And so I would rather have you go ahead and do this calculation just like all the rest, and then use the 100%, the totaling 100% thing as your check. So I am going to do that really quick. I'm going to do a check on that. So I've got 20.5 plus 10.3 plus 13.1 plus 6.41 plus 53.8. I messed something up. It came out to 104%. What did I screw up? Well, I was right about basically doing each of these separately and then adding them to make sure you get 100, because I messed it up. I must have punched something wrong in my calculator, and when I went back to check, though, the nitrogen was wrong. The nitrogen was off. So I'm going to redo this calculation for nitrogen very quickly and get this fixed, I hope. So let's erase that. I will redo this. 28. I think I just punched something wrong in the calculator. Divided by 312. And I get 8.97. 8.97%. So this is 8.97%. Now I'm going to add them again, and hopefully this adds up to 100, because when I did it before, it only added up to like 104. So it was messed up. So 53.8 plus 6.41 plus 8.97 plus 10.3 plus 20.5. I get the number that I get it when I add up all of these is 99.98%. So again, that small amount there is just the rounding that we did on some of these answers. You get a number that's that close to 100, and you're doing fine. All right, so again, use the added percentages to your check, and you'll keep from making dumb mistakes like the one I just made.